Now, we're reaching for the stars with our next guest. New pictures released by NASA are out of this world, quite literally. The James Webb Space Telescope has captured images of the pillars of creation where new stars are forming within dense clouds of gas and dust. OK, let's bring in ANU astrophysicist and cosmologist Dr. Brad Tucker. I've always wanted to interview an astrophysicist. Brad, great to see you. The pillars of creation, they were first made famous when captured by NASA's Hubble Space Telescope in '95. What is the significance of these new images?
Yeah, look, thanks for having me on. Hopefully I won't let you down in terms of the first one. And then, as you said, in '95, the Eagle Nebula, as it's formerly called, was imaged by Hubble. And the problem with Hubble is it's looking at optical colors. Now, that's not a bad thing. Those are the colors of light we see with our eyes. But dust blocks or absorbs optical light. So, in fact, you can't see it. But with James Webb and the infrared, you can kind of see through the dust. And you're seeing that side by side with the new image on the right. All of that black darkness is actually gone, and now you can see more structure underneath. And that's been the power of James Webb. By looking in the infrared colors, you can see things normally not visible to Hubble, and therefore see other things going on. In fact, seeing even more structure of all of these stars, because the name Pillars of Creation is this is a place where stars are actively being born as we image it right now.
Fascinating. And what does it mean for research? How will it help us?
One of the big questions is when these baby stars form, they kind of blow off a little bit of gas. They kind of let loose. They have a tantrum, essentially. And when you look at these pillars of creation, you can see kind of these wavy patterns and these nodules. And this is actually these waves of gas being shot out of these new stars. So you see kind of these big blobs, but then you see these waves coming off of it. And that's some of those gas being shot off essentially from those new stars. And that process is very unique because ultimately when that stuff gets shot off, that gas either goes further into space or eventually can even form other stars or the planets around it. So you're getting glimpses into the formation of planets as well around these stars in real time. And, we can't wait for a star to go through its whole life cycle. So seeing images like this allows us to see, kind of the infancy of a bunch of stars to understand how they start off in their lives.
And this kind of technology, it's going ahead in leaps and bounds. How hard is it? How much work went into getting these images back to us?
Look, I mean, it was almost 3 decades worth of work because, they built a telescope 6.5 meters wide. The mirror itself is 6.5 meters wide. And you had to send it into space that had to work and build cameras. And by looking in the infrared colors, like we were seeing just there, they operate at very cold temperatures. So you actually have to keep everything ultra cool and stable and not destroyed by radiation from the sun. It has to be able to communicate, operate remotely. So not only do the images have to be taken by the telescope, they have to be transmitted 1.6 million kilometers back to Earth. And we're talking about tons of data being sent down all the time through the NASA Deep Space Network, one of which is outside Canberra at Tidbinbilla. So it's a huge amount of things. And then all the processing and analysis that goes in once those images arrive. And, we waited decades for this. And it's for images like this that really are truly breathtaking. They're as scientifically interesting as they are beautiful.
That's amazing. And I bet you get asked this question at dinner parties all the time. This is the $1 million question. Now, if this is just one part of space, what else is out there?
Look, and I think that's a $1 billion question, $1 trillion, and that's the point is, this is one little pocket of space, 6.5 million light years away, 6,500 light years away, rather, not even outside our Milky Way, where our galaxy is one of potentially 2 trillion galaxies, all which have about 100 billion stars, all which have planets, all which has moons around it. It's an awfully big place. It's like trying to want to see every single part of the Earth. It's almost unfathomable in its question. And yet, tools like this allow us not only to see new pockets of the universe that we just couldn't see before, but now see new parts of the universe in completely new light. It really has been upgrading our 1080p television to 8K. It just doesn't compare anymore. And I think that's the exciting thing. All of the surprises of both the views that we've already had in new light and just new parts of the universe we've never seen. We're on a decade of discovery, if not more.
All right. The other question you often get asked at dinner parties, I'm sure, is the Big Bang Theory. It's not just a TV show, is it? What actually is the Big Bang Theory?
Look, we genuinely believe it was essentially a massive eruption of energy, so to speak. And it wasn't an explosion. It was the releasing of all of the contents of the universe at one single point. And it becomes quite interesting because we don't actually know, and we can't actually see the Big Bang. It is so far away, we can't see it. We can only understand how all of that energy is turned into today. And one of the big goals of James Webb is to see those very first stars formed after the Big Bang, to at least tell us where the starting point is.
Brad Tucker, fascinating. We could talk all night. Thank you for joining us.